Hi, welcome to the video on random forest. By the end of this video, you will be able to describe the process of bootstrap aggregation, perform bootstrap aggregation, work with one of the most popular random forest models, explain the concept behind random forest. In the last video, we understood the fundamental idea behind the ensemble techniques. In this video, we will be looking closer at the bootstrap aggregation or the bagging technique in detail. If you recall, ensembling is about combining several diverse models to generate better results. But how do we introduce this diversity in the models when we have a limited number of observations in our dataset? One way is to use a combination of two predictive models like linear regression and decision tree. However, these are only two models. What if we want to build 10 diverse models and maybe 100? Obviously, the number of algorithms are very limited. So what should we do? Another way is to somehow manipulate the data that we feed to each model so that each model is different from the other in some way. Let's understand this with the help of an example. Consider that we have 26 unique observations representing the total data that is available with us. The most intuitive way to build a diverse model using this data is to equally divide it between the number of diverse models that we want to build. Let's consider that we want to build 3 diverse models, so the data partitions would look something like this. But there is one issue with this approach, which is clearly visible. Can you guess? The data which each model is getting is a very small partition of the actual dataset. As a result, only a small portion of the underlying pattern is learned by each individual model, and each of them are likely to overfit. Now, to overcome this issue, we use the concept of bootstrap sampling. In bootstrap sampling, each model is given a random sample from the original data with replacement. To create sample 1, we select 26 values from the original data at random. For example, to select the first value, we can randomly pick up any of the 26 values and suppose that comes out to be A. So the first element in our sample is A. Now to select the second value, we will again randomly pick up any of the 26 values from the original dataset, and let's suppose we end up selecting A again, and hence the first two elements of our sample 1 are A, A. In similar fashion, we will pick up the third and fourth value at random, and let's suppose B and I get selected. In this manner, we will continue till we have selected 26 values. Since every time we are selecting the values at random from the original dataset, it is possible that some of the values might repeat itself in the sample, as we can see here that we picked value A at 1, 2, 15 and 23 position. Similarly, we will create sample 2 and 3. By doing this, each model gets slightly diverse but full size of data. This fulfills the requirement of models having diverse data and the significant size of the data. Note that in any sample, some of the observations could be repeating and some of the observations are entirely missing. Bootstrap sampling is the core idea in the bagging technique. Bagging primarily focuses on bringing the diversity in the model using diverse data. We will now be looking at a special case of bagging technique known as random forest. In the random forest, we use the decision tree as the base model. It is one of the most popular ensemble algorithms. Now we know what bagging is. We will begin the process with complete training data. As random forest lies under the bagging technique, we will create bootstrap samples of the training data for each decision tree with the random forest. The number of bootstrap samples would depend on the number of models we want to train. The number of bootstrap samples would depend on the number of models we want to train. Say we build 10 models here, so we will create 10 bootstrap samples. Now on each of these bootstrap samples, we will build a decision tree. So here, we will train 10 decision trees, each on a different bootstrapped sample of data. And each of these generate a separate set of predictions based on the subset of data it received. Lastly, we will combine multiple trees to get the final output, and hence it is called a forest. But why random? Is this because we use random bootstrap samples? Well, that's partially correct. Along with random sampling of the data point or rows, random forest also performs a random sampling of features. Remember that the data point or row sampling is done at the tree level, which means every tree gets a random subset of data points. But feature sampling is slightly trickier than the row sampling. This is because feature sampling is done at the split level and not at the tree level. Let's dive deeper into the feature sampling for random forest. Say we have the following 9 features in my dataset from V1 to V9. Now in a simple decision tree, all these features from V1 to V9 are used at every node to decide the best split point. But for a tree built in random forest, a subset of features is selected for every node. So let's say the first subset is V1, V3, V4, V9. Then these features will be used at the root node to determine the best split. Now for the next node, another subset of features, say V2, V4, V7, V8 is selected. And the same process is repeated for every node in the tree and for every tree in the forest. And this gives random forest a twofold effect of bootstrap sampling as compared to simple bagging with decision tree as the base estimator. Now in the next topic, we will be working on the implementation of random forest algorithm and learn about the hyperparameters tuning of the random forest model.